All right, let's go and do another solving trigonometric equations involving half angles and all kinds of hairiness there. All right, so I want to be able to solve for x, so I'm going to go ahead and replace my sine of x over 2 with plus or minus the square roots of 1 minus cosine of x over 2, and that's all minus cosine of x equals 0. Now what I want to do is this, is that even though we normally want to keep everything on one side, but I'm going to move this to the right so I could square both sides. Okay, so I'm going to leave my radical 1 minus cosine of x, leave that over there, but I'm going to move my cosine to move it on the right. Now, if I square both sides now, okay, so I go like this, I square that side, and I square this side, cool, I get my radical disappears, 1 minus cosine of x over 2 equals cosine squared of x. That's rad. Let's multiply both sides by 2. I'm going to multiply this side by 2 here. So we get 1 minus cosine of x equals 2 cosine squared of x. All right. And now let's move everything now to the left side because it looks like we're going to have a quadratic. Okay, so 0 equals 2 cosine squared of x. Add my cosine of x, and then subtract 1. So now it's a quadratic, and we can factor this. Okay, so I'm going to go ahead and set up my parentheses. So these two values must give me 2 cosine of x squared. So that's 2 cosine of x, cosine of x. I need to get negative 1, so I know I'm going to do 1 and 1, but let's see here. I want the middle term to be positive, so 2 cosine times 1 is a positive, and then I want this to be minus so that I could subtract 1 cosine from 2 cosine to get my 1 cosine in the middle. So set each one equal to 0. So I get 2 cosine of x minus 1 equals 0. And I get cosine of x plus 1 equals 0. So if I add 1 and then divide by 2, I get cosine of x equals a half. And then here I get cosine of x equals negative 1. All right, let's solve now. So that means over here we get x equals pi over 3. And let's see, a half. Let's see. And then 5 pi over 3. And over here, cosine of what is negative 1? Well, that's just going to be x equals pi. Okay, like I said in last example, this one is going to have an extraneous solution. And I know to check for that because I squared both sides. That's a strong indication. So we're going to go ahead and check our answers right now. Okay, so the original equation was sine of x over 2 minus cosine of x equals 0. All right, so let's just start with pi right here. Okay, so if I start with pi, that's sine. I'm just replacing x with pi now. That's pi over 2 minus cosine of pi equals 0. So it has to equal 0 in order for this to be a solution. Well, sine of pi over 2, let's see here, that's the 0.01, so that's 1, minus cosine of pi is negative 1. Uh-oh. Is 2 equal to 0? Nope. So that's why pi would be called an extraneous solution. So we pretty much just cross that one out. It's not a solution because we just plugged it back in. Let's try the other ones here. Let's do a pi over 3. So sine of pi over 3 all over 2 minus cosine of pi over 3. Okay? Well, this is the same thing saying 3 times 2 is 6. So that's sine of pi over 6 minus cosine of pi over 3. Oh yeah, and we want this to equal 0, and hopefully it does. So sine of pi over 6 is a half. Cosine of pi over 3 is a half, and we get 0. Wha-bam! 0 equals 0. And if you were to do the same thing for 5 pi over 3, you would get 0 as well, which means that the only two solutions are pi over 3 and 5 pi over 3.